In this video, we're going to take a look at how to sketch curves. The steps to sketching a curve is first find the domain, the intercepts, the asymptotes, and the end behavior. And we're going to do all of this from the function f of x. And then step 2 is do the first derivative test so we can find our relative minimums and our relative maximums, and so we can find our increasing and decreasing intervals. And then we're going to do the second derivative test to find our inflection points and our concavity. And then we're going to sketch the function. In this first example, we have f of x is equal to 1/3 x cubed minus 9x minus 2. So from the function itself, I want to find the domain. So our domain is all real numbers, because we have a polynomial, negative infinity to infinity. Our y-intercept, which would be probably the only one I'm going to find here, would be, because it's cubic, it's going to be hard to find the x-intercepts. So if we put 0 in for all the x terms, then we get -2. So 0, -2 is a point on our graph. So that's one of the intercepts. Now, because we have a polynomial, we don't have any asymptotes, but we need to find end behavior. And if you remember back from limits, when we do limits to infinity and negative infinity, we find end behavior. So I want to do the limit as x approaches infinity of f of x. And when we put infinity into this function, we get infinity back out because we're cubed. And then limit as x goes to negative infinity. Remember, when you cube a negative number, it's still negative, so we have negative infinity. So that means on the right side of our graph, as we go to infinity, we're going to go increase forever, go up forever, and then as we go to the left, we're going to decrease forever. And now we're going to take our first derivative test. So f prime of x is equal to x squared minus 9. And now we want to set that equal to 0. So x squared minus 9 is equal to 0. And solve it for x. So x squared is equal to 9. And x is equal to plus and minus 3. So we have two critical values. And now we want to do a sign chart. So we have our sign chart. And -3 and 3. And now we want to test all our intervals. So f prime of -4, f prime of 0, f prime of 4 is equal to. So f prime of 4 is 7. F prime of 0 is -9, and f prime of -4 is also 7. So we're positive in this first interval, so that means our function is increasing. We're negative in the middle interval, which means we're decreasing. And then we're positive in the last interval, which means our function is increasing. And now we want to do the second derivative test. So f double prime of x is equal to 2x, and set that equal to 0. So 2x is equal to 0, and x is equal to 0. So we're going to do a sign chart for our second derivative test, with 0 being our critical value. And when we test f double prime of -1 and f double prime of 1, when we put -1 in, we get -2. And when we put 1 in, we get +2. So we're concave down left of 0, and we're concave up right of 0. So this is everything we've learned up to this point, and now we need to learn how to put it all together. So now we want to take a look at graphing this. So first thing we want to do is plot all the points we know. So here we know that 0, -2 is a point on the graph. It was our y-intercept. So we're going to have 0, negative 2. So we know this is a point on the graph. And then we can plot our relative mins and maxes. We didn't look at that yet. So here we are increasing and then decreasing. So we had a max. So we need to find f of negative 3 to find the y value of that. And then here we're decreasing and then we're increasing. So we have a min, f of 3. And when we put negative 3 into our function, 1/3 x cubed minus 9x minus 2, we get 16. And when we put 3 in there, we get negative 20. So those 2 points are points on our graph as well. So we know 3 and then down to negative 20. So I'm just going to put it down pretty low. And we'll call this point 3, negative 20. And then we have negative 3, positive 16 up here. So this is negative 3, positive 16. So these are our mins and maxes. This is where we touch our y-intercept. And now we need to look at each of the first and second derivative tests. So from negative infinity to negative 3, we're increasing, and we're concave down. So here we can start at this maximum point and draw our curve down and concave up. And now at this point, we're concave down still, and we're decreasing from negative 3 to 3. But our inflection point is at 0. So here at this point, we need to change concavity. And now we're concave up the rest of the way, and we're decreasing to 3. So we're going to go down to 3, and then back up to infinity. And this would be a rough sketch of this function using the first and second derivative test. So f of x is equal to 1/3 x cubed minus 9x minus 2 is roughly this picture.